Hello everyone, welcome back to Zeey. In this video we try to uncover the different and strange possibilities of wormholes. Subscribe to our channel and follow us. The concept of an Einstein-Rosen bridge, mostly known as a wormhole, is one of physics' oddest theories. Wormholes have been depicted numerous times in science fiction, perhaps most famously in Star Trek Deep Space Nine, and if they do exist, they offer two intriguing possibilities that could allow us, or someone else, to hack the universe and travel almost instantaneously from one point in the universe to another, or even from one point in time to the past. This has prompted physicists to speculate on the existence and plausibility of wormholes, as well as to try to close the loophole in relativity that appears to allow for them. This has resulted in an ever-expanding set of wormhole possibilities, ranging from black holes being wormholes that might rip the very fabric of spacetime and bend it back on itself to allow a connection between two distant points in the universe that wouldn't necessarily exist otherwise, to the idea of tiny quantum-scale wormholes constantly popping in and out of existence, one of which may have enlarged and precipitated the Big Bang, at least according to one theory. The reality is that we've never seen anything approximating a true wormhole, but we've seen signs of something similar. Vaguely, consider a black hole. If wormholes are time machines, then black holes are also time machines in the sense that you can get very close to one and move faster into the future than you can standing in empty space without any gravity sources. Consider quantum entanglement, in which two entangled particle states can change at the same time. What binds them together? How do they act at the same time? Why does it appear that there is a built-in barrier against exploiting this effect to convey information faster than light? Is this prohibition also applicable to wormholes? Maybe. If the interiors of black holes are in fact wormholes, then it is impossible to survive crossing them. You get spaghettified long before you reach the singularity, and time dilation becomes so severe that the singularity simply constantly lies in your future, or at least the particles you were previously formed of, and you're simply locked inside the event horizon forever. I understand how you feel, having plummeted into the event horizon and all. That is, assuming wormholes exist at all. There are other physics alternatives that nature does not prohibit, at least as far as we can determine from the arithmetic, yet may not exist practically. This includes exotic stuff, materials we've never seen and have no idea how to manufacture but are nevertheless theoretically permitted by physics. Some of these materials are necessary for the concept of stable traversable wormholes to work. You could, for example, generate rings of unusual matter, in this case anti-gravity negative mass, to keep the wormhole open. At its most basic, negative mass is simple to imagine. If you have a block of material that weighs 1 kilogram, you could envision its negative component as weighing, if you will, -1 kilogram. While this may appear to be simply reversing a number by adding a negative sign, mathematics like this has a tendency to accurately explain the cosmos, which is why physics is filled with equations. Granted, if nature creates such a thing, we're unlikely to observe it because anti-gravity objects are rare to be found near gravitational sources like Earth, but it does present a hypothetical framework for working with wormholes. And if it turns out that you can physically work with them, a civilization that does so will own and wield one of the universe's greatest powers. Such a civilization would have perfect mastery of both distance and time, making Doctor Who operations seem archaic. We're all familiar with the properties of wormholes, which are frequently shown in science fiction, but here's one that isn't typically seen: the phenomenon of gravitational lensing. Wormholes could be among the most powerful gravitational lensing objects in the cosmos. Gravitational lensing is well known and can be observed in this James Webb Space Telescope image, where the gravity of foreground galaxies distorts and bends the light from galaxies in the background. This is true for any gravitational source. The reason we see portrayals of black holes, such as a Gargantua from Interstellar, with a ring of light around the event horizon is because the black hole is warping the light from its accretion disk passing behind it around to the observer. Wormholes may perform the same thing, and if they exist they may be observable. The issue is determining how to differentiate the gravitational lensing effect of a wormhole from that of a black hole. Recent work by Mian Zhu and colleagues at the Hong Kong University of Science and Technology demonstrated that, while extracting the signatures of black holes and wormholes bending light would be difficult, it might be doable, especially if you look at clusters of them. In a word, if you look at an item that is being gravitationally lensed by a black hole, depending on the circumstances, you should see any number of copies of the thing behind it. However, it turns out that a charged wormhole will either produce 1 or 3 images. If you see 3, one of them should be brighter than the other 2, allowing you to detect and distinguish a wormhole from a black hole. Furthermore, this effect has the potential to amplify the lensed light by a factor of 100,000, allowing wormholes to be used as extremely powerful telescopes. Hello there, shrieking alien technosignature. Indeed, if you came across a signature wormhole in a star system with habitable worlds, you'd have to ask if it was man-made, especially if it can ever be proven that huge wormholes do not exist in nature. However, there is research that suggests that wormholes, regardless of how they are produced, may be fundamentally unstable, especially if something attempts to travel them. They appear to be doomed to collapse instantly, creating a universal prohibition, particularly to preserve the chronology should someone attempt to influence history. However, there may be a loophole. This takes the form of electromagnetic energy passing through a wormhole. Ben Kane and colleagues at the College of the Holy Cross in Massachusetts demonstrated that while matter passing through a wormhole would collapse it, it would not do so instantaneously, and you might be able to squeak in an electromagnetic signal just before it implodes. To keep this model open, you must additionally invoke exotic matter. So you might be able to open a wormhole with the exotic stuff, send a probe through and have it send you a signal about the environment on the other side of the wormhole before it collapses. This is troublesome because the models revealed that not all of the matter made it through, so you may wind up with a non-functional partial probe on the other side, but the work suggests that wormhole communications of some kind are theoretically possible. They may, however, break causality if the wormhole leads to the past. This is the major issue with any time travel or faster-than-light travel which has the connotation of time travel. It's the well-known paradox that if you go back in time and prevent your parents from meeting, you'll never be born and so should not exist. Everything we can measure about the universe tells us that it does not like this. The speed of light is a nice example here. The speed of light is often considered to be the universal speed limit, however it is generally shown as the quickest anything, in this example a photon can move. But it goes beyond that. We know from Einstein that the faster you move, the more time dilates and the more energy you require to get up to speed. In this context, the speed of light is also the speed of time, because at the speed of light, time simply stops. This results in the peculiar life of a photon, which does not experience time. It is emitted and absorbed simultaneously, regardless of how much time it takes to travel a distance in our frame of reference. However, if you travel faster than light, you may theoretically travel backwards in time. This is the concept of the tachyon. Physics does not forbid faster-than-light particles from traveling back in time, but they could never slow down to meet the speed of light. Again, this is a mathematical exercise in adding a minus sign to numbers that may or may not be practical. But the point is that accelerating matter to the speed of light takes unlimited energy, which is more than the cosmos has. In other words, absurd conditions are required to overcome the time travel problem by traveling faster than light. You can experiment with wormholes and black holes, but they may also be forbidden from being traversed. You're simply not allowed to. And this safeguards the timeline, otherwise, the cosmos would not function as it does. Perhaps there are universes in the multiverse where these laws work completely differently and there is no time continuum as we know it, but rather everything is always changing. That would be a difficult universe to inhabit. However, we frequently consider black holes and wormholes to be objects of travel. We imagine them as something akin to a train that could transport you across space and time. But it could be the wrong approach. They could just as easily be telephone lines used simply for communication. Or they could be used for something we're only now starting to think about, like David Kipping's Halo Drive, in which binary black holes are utilized to accelerate a spaceship by shooting a laser that gravitationally lenses around and gathers energy from the collision. However, there could be another application entirely. Dvali and Osmanov's research indicates that while black holes may produce excellent quantum computers, wormholes are unlikely. Quantum computers in general are beyond useful, which is why we pursue the technology at our current technical level. They can be several times quicker than standard computers and use almost bulletproof encryption. This suggests that the most effective quantum information repository may be a black hole. Black holes, or at least the area around them, are incredibly active objects. Their accretion disks accelerate matter to relativistic speeds, especially immediately above the black hole's event horizon. This effectively allows an alien civilization to tap vast amounts of limitless energy, and it may make black holes with accretion disks the place for SETI to look for technosignatures rather than planetary systems, which advanced aliens may abandon in search of useful black holes. Work seeking for technosignatures in this type of environment, as well as potentially around neutron stars, is in its early stages, indicating that we may be missing obvious technosignatures in the galaxy simply by looking in the wrong areas. However, converting a natural black hole into a quantum computer may not be ideal, and it may be preferable to use an artificial one. It would be a miniature black hole formed in an accelerator, which is something theoretical physics hopes to perform in the next years. All black holes generate Hawking radiation, which causes them to evaporate, but minuscule black holes emit it more intensely and in a different spectrum than, instance, a supermassive black hole at the core of a galaxy. An artificial one utilized for computation may release detectable signature particles such as neutrinos, which could lead to the detection of a technosignature someday. However, observing neutrinos from an artificial black hole running a quantum computer would be a strange experience for us. We are nowhere near that level, thus we would be witnessing proof of a very advanced and mature alien culture. If it can still be called a civilization, it may be a single machine beyond artificial intelligence but superintelligent, that computes using the very rules of the universe itself. We may never know what motivates such an entity. Instead, it may compute silently around its black hole and never choose to interact with humanity. And we'd have no idea why it exists at all. Alright, that is all for this video. Thanks for watching, everyone. What are your thoughts? Is there anything you like to add? Tell us in the comments and subscribe to our channel for regular, in-depth investigations of the fascinating, strange and unknown facets of our beautiful universe.